Welcome to Precalculus Concept 17b. We're going to solve rational inequalities. So in the last video, in 17a, we took a look at polynomial inequalities, and in this video, we're going to talk about rational inequalities. The idea is exactly the same, but I want to make sure that you guys understand that a polynomial inequality is an inequality that has a polynomial in it versus a rational inequality is an inequality that has a rational function in it. So there is a difference between the two, but the idea is still the same. We're going to find critical points and then take test points in those regions. So let's get started here. Okay, so here's example number, or box 2, it's an example. It says solve 3x plus 3 over 2x plus 4 is greater than 0. Okay, before we begin, I want you to understand that when something says it's greater than 0, that means that the graph is above the x-axis. So the fact that this says greater than 0 means that we're looking at for points on the graph when it would be above the x-axis. I do have the graph here graphed for you, but we're not going to always necessarily have the graph. So we want to be able to get this solve this without actually looking at the graph, but we do want to be able to do both. So the first thing that we're going to do is we're going to find our critical points of a rational function. So we're going to set the numerator to 0, and then we're going to solve. This is going to give us our x-intercept. Now I can see the x-intercept right now is at -1, but I'm going to go ahead and show you how to get it algebraically. We want to set the numerator equal to 0. So we're going to set 3x plus 3 equal to 0, and we're going to solve. So I'm going to subtract 3 from both sides. So 3x is equal to -3. Divide by 3, so x is equal to -1, which is clearly indicated on the graph, but that's our first critical point, finding the x-intercept. The second critical point is to find the vertical asymptote, which I clearly have labeled right here as the value of x is equal to -2. So how do you get that? You find any vertical asymptote on a rational function, you set the denominator equal to 0, and you solve. So I would get 2x plus 4 is equal to 0. So 2x is equal to -4, so x is equal to -2. Okay? So my critical points that I'm working with here are the x-intercept of -1 and the vertical asymptote of -2. So the third thing to do is go ahead and set up your number line. Okay, I like to put 0 on the number line just so I have a reference point. So that means that -2 would be somewhere over here, and then -1 would sort of be exactly in the middle. So at -2, I know I have a vertical asymptote, and at -1, I have an intersection point, so I know that I have a critical point there. So all we gotta do then is take test points in each of these regions over here. So there is, to make sure we understand the regions, there's this region here, there is the region that's in between, right here, in between the asymptote and the intercept, and then there is the region that is to the right, so all the way over here, all right? And we are looking for values that are greater than 0. So you can take any test point that you want in any of these regions, and you can plug it back into the original function and see. So I would take maybe the test point of -3. I would take the test point of maybe -1/2. And then I would take a test point of 0 over here. Okay? So what you would do is take these and put them back into the rational function. So if I took 3 times -3 and then added 3 divided by 2 times -3 and added 4, I would evaluate this, and I'm evaluating this region right here, the yellow region. So this would give me what? -9 plus 3 over -6 plus 4. -9 plus 3 is a -6. -6 plus 4 is a -2. Negative divided by negative is a positive, and that's what we're looking for because it's greater than 0. So in this region, things are going to be positive, which clearly it is. From just looking at the graph, I can see that it is above the x-axis. Okay. Okay, now I want to go maybe take test point -1/2. So, or -1 1/2. Sorry, -1 1/2. So -3/2. So if I took -3/2, I would get a negative point down here, and then if I took 0 and beyond, I would get a positive right there. So how do I write the answer to this thing? It would be anywhere from -infinity all the way up to -2. Okay, I don't want to include -2 there because it's not part of my domain. And then I would include this region here, right? From the union with -1 out to infinity. So this would be the answer to solving this rational inequality. Box number 3 is another example, and I'm showing you this example only because there's lots of algebra involved in this example, and I want to make sure that we cover it. So let's go ahead and solve x plus 1 over x plus 3 is greater than or equal to 2. So notice that it's set greater than or equal to 2, and we want them to be set greater than or equal to 0. So if I start with x plus 1 over x plus 3 minus 2 is now greater than or equal to 0. So that's your first step, is to get 0 on the right-hand side. Then I need to add these two fractions together, so I need to multiply by the common denominator of x plus 3 over an x plus 3. So we would have this. We'd have x plus 1 minus 2 times an x plus 3, all divided by x plus 3. So let's just keep mathing this thing out and doing some algebra, as you guys like to say. So x plus 1 minus 2x minus 6 over x plus 3. This is going to give me x minus 2x, negative x. This is going to give me 1 minus 6 is negative 5, all divided by an x plus 3. And now this thing is greater than or equal to 0. All right, now that I have this set up, I can go ahead and find my critical points. So if I set my numerator equal to 0, so negative x minus 5 is now equal to 0. So negative x is worth 5, so x is equal to negative 5. So there's one critical point. The other critical point would be obviously the domain, which would be negative 3. So at negative 3, I know I have something else going on there. So then I would make my graph, okay, into my regions here. So I like to put 0 on the graph. Here's negative 5. That means negative 3 is right here. So I have these 3 regions to check on the graph. So you can take any test point that you want that's in those regions. So I would take the test point maybe negative 6. I would take the test point maybe negative 4, and then I would take the test point of 0. If you take negative 6 and plug it back in, you would get a negative 1/3. Negative 1/3. So that'd be down here. If you take negative 4 and plug it back in, you would get a positive 1, so it would be above the x-axis there. And if you took 0 and plugged it back in, you'd get a negative 5/3, so it would be below the x-axis there. So which ones do we want? We want the values in which these things are greater than or equal to 0 here. So the only place that occurs is between negative 5 and negative 3. So right here, negative 5 and negative 3. But remember, negative 3 is not a member of the domain. So then the answer would be just from negative 5, including negative 5, up to negative 3, and not including that one. We include the negative 5 because it's an intercept. We do not include the negative 3 because it is not part of the domain. And then, of course, if you actually look at the original graph, which I have here for you, you can see here's the point negative 5, okay? And then here's the point negative 3, negative 1, 2, 3, right here, okay? So in between this region right here, all of this stuff is greater than the number 2. And here is the line y equals 2. So that was kind of a different example with some algebra, but still one that we should be able to do. Okay, that's it.